Hi everyone. Okay, science for today is just only going to be review and hopefully very helpful to you. Okay, first thing I'm going to do is quickly review the kind of guide for the little show what you know tomorrow. You're able to use your notes. So hopefully, and your visual pages that you guys have been making. So hopefully it's kind of not that hard to do, especially with all those great resources in front of you. Okay, so here are the few things. All right. So, okay. All right. So provide evidence of the properties of air and identify examples of these properties in everyday examples. So knowing that air is invisible and is made up of gases, knowing that air takes up space, knowing that air has mass and density, and knowing that air exerts pressure. Okay. So what I'm going to do is I'm going to give you a hypothetical situation. I'm going to say, okay, in this situation, which of these properties is being shown? So as long as you understand what they are, then it should be kind of easy to match them up. Okay, or it's going to all be multiple choice. Provide evidence that air is a fluid and is capable of being compressed, and identify examples of these properties in everyday applications. So for that, we need to know a little bit about the molecules of the air and how when it's fast, it's moving quicker, right? And then the molecules when they're a little bit slower, a little bit colder, they don't really move as fast. So that, and then knowing that the molecules move in air, how the molecules can be compressed, right? We learned about that when we talked about compression of air. Okay, the next one is describe and demonstrate instances in which air movement across a surface results in lift, which is Bernoulli's principle. Okay, you have to know Bernoulli's principle, that high airspeed is, I'll be asking you out loud, low air pressure. Low airspeed, so normal moving air, would be higher relative air pressure, okay? So that is important. If you feel like you need to review Bernoulli's principle, go back and rewatch those lessons on Bernoulli's principle. I'm going to come back to that in a minute also. The next thing is recognize that in order for devices or living things to fly, they must have sufficient lift to overcome the downward force of gravity. Okay, that one's yeah, okay, so it has to be able to have enough lift so that the gravity is counteracted, okay? The next one is recognize that aerodynamic design increases streamlining to reduce drag. So basically, the less stuff that's on the less surface area, that's what we talked about, surface area to have blocked spaces of the air, then the more aerodynamic it is, right? So we're talking about if we're comparing, for example, an F1 car to a huge transport truck, which one is more sleek? Which one is more streamlined? Obviously the race car, right? Compared to the huge semi truck. Yeah, more block surfaces. So even if you're comparing something that looks like this, right? Something that looks like this, what would be more streamlined? Obviously, this is going to cut through the air better than this. Okay? If you're kind of thinking another way to think about this is in the pool, for example. Say that you're swimming and I don't know if you guys have ever done this, you have to hold the flutter board up like this, then you swim. Oh, that's so hard compared to with the flutter board flat. Okay? So that could be an example that you might want to show for that design. Okay, so that was that one experiment that I'm going to come talk to in a minute for this seesaw stuff, for the aerodynamic design. So I wanted you guys to come up with a design that shows, oh yeah, this is good aerodynamics, and then this one doesn't have as good aerodynamics of the same object. Okay, and I said try to use something other than a car, because that's how all of our examples were, and it's kind of obvious, right? If that's what we saw in the wind tunnel too, right? If it's super sleek, it's going to be way more aerodynamic compared to if it has it's more boxy, the older cars, right? Before they started doing this wind tunnel testing and recognizing that okay, we're going to get way better fuel efficiency on these cars if they're more sleek. It's not as much wind to push through, right? Not as much air resistance, not as much drag being created. Then people aren't going to have to spend as much money on gas. So, yeah. Okay, so anyway, that's another kind of like realistic example. But again, I don't really want you to use cars because I've already talked about cars over and over and over and over and over. Okay, and then, okay, so I think there's going to be a couple of these from the Streamline Design that if you guys want to share, tomorrow we're going to be doing a Zoom at 1 o'clock to launch off our aerodynamic Show What You Know. And then I think it'd be so cool if some of you guys have designs that you're kind of proud of and that you want to talk about to show to the class. And then I'll tell some of the ones that like I can share a couple other with you as well. But I want you to think about it first. Okay, then the last thing is identify the 4 forces of flight and relate them to practical situations. So again, that was what we did that whole page of, right? Lift, gravity, thrust, and then drag is the backwards force. So just like thinking about like relating those concepts to practical situations. Okay, so that is tomorrow. It's all going to be 100% multiple choice. Okay. I think there's like 15 questions in total. So it shouldn't, and again, you can use your notes. So if you were in normal class, you would not be using your notes. So this should be like easier to do. Okay. Alrighty. So next thing I wanted to talk about was our, okay, this. All right. Bernoulli's bridge. First of all right, guys. Okay. I've marked these. Okay. I would like you to go in and look at them because if you did not do very well on this, I am being the nicest person ever and I'm going to take another like hour of my time to go back and remark these because I've written in some marks that I don't think that you guys are going to actually want. So if you make edits and you hand them in today, like they need to be in before tomorrow morning at 8:30, then I will remark it. Okay, for the Bernoulli's bridge experiment. Okay, so this is what you had to do. Okay, I feel honestly like I'm kind of a bit of a broken record here saying this, and you guys have to know your grade 7 teachers are not going to do this for you. Okay, so hypothesis: what will happen to the bridge when you blow under the bridge? Write down. Okay, I think something. Hypothesis should have the word because. Because why? What do you already know that's helping you make this decision? Okay. All right, then you needed to cut a piece of paper, okay, like this. And then you need to fold it like this. I was not gonna tell you how to do this because you guys need to be able to figure this out. Okay, then, okay, so, and I'm on step number 1 is using a strip of paper, build a bridge that looks at the picture above. Ta-da! Number 2, set the bridge on a table. Gently blow under it, between the table and the bridge. Okay, so step number 3, some people didn't even do that. Okay, so here is my imaginary table, my iPad, okay? I've set it on the table, and I'm going to blow underneath the bridge, between the table, my iPad, and the bridge. Watch what happens. Try varying the speed. So try changing the speed at which you blow. Okay, watch. What has happened to the top of the bridge? Can you see? Okay. I'm not going to say any more than that. I just did it for you. So now you need to do this. Observations. Label where the air is moving quickly. So here you should have a drawing in observations. This should not really be a whole paragraph of printing. You should have this sketched out and drawn. Okay, then this. Label where the air is moving quickly and the associated pressure. That is the key scientific concept from Bernoulli's principle, okay? Where is the air moving quickly? What is the associated pressure? What is happening when you blew under the bridge? Analysis. What is causing this to happen? If you really want to do an excellent job of this, you would also label the other air. So the air moving under the bridge is one thing, but then there's also air always around us, which there's another concept that you know about that. Speed and then pressure, okay? There you go. That's all I'm saying. So if you want to go back and make a couple of edits, you need to have that done by 8:30 in the morning, or else, class, I'm writing down the mark that I have for you written that I've messaged that you're going to see in my comments. Okay. Alrighty. That's the first thing. Now, the second thing is this, which is okay, aerodynamics design. Okay, again, I feel like a little bit of a broken record here. Okay, so guys, you need to do this. This is counting for a mark. If you do not have it done, I'm writing in a B, which sucks. You do not want to have this. The whole point of these assignments is to be like helping your mark a lot so that when it comes to like a quiz or show what you know or whatever, then this is like buffer room so that when you have like that maybe the harder stuff, it's not gonna count, it's not gonna hurt you as much. But if you have a B for something like this, then even if you did super well on the final, it's not like it will have a negative impact. Okay, all right. Plus, this is helpful because it's basically like giving away answers for what's going to be one of the questions in the show what you know. Just like the Bernoullis bridge lap, there's going to be a question that's like pretty much the same as that. So you have to understand the concepts. Okay, now this one. Okay, design your own experiment to prove how aerodynamics can be shown. How does the change in surface area affect the amount of drag? Question, does the change of surface area create more or less drag? I think when you change the surface area, by increasing it, the drag will, what do you think? Okay, then you're showing a design. Maybe I'm going to show that design of the truck. Okay, like the one from the GMC lab that we saw in our video the other day. Okay, poor design. Model T Ford, invented forever ago, right? Poor design of a truck. Lots of block surfaces. Kind of looks like a box. Not going to move very fast, right? Like it's going to have more resistance. Good aerodynamic design. I'm going to show a truck. I'm not going to show a race car because I'm not showing an improvement on the aerodynamics of that one item. Okay. I'm going to show on my truck, like F-150 or GMC or whatever it is, what would an improved aerodynamic design look like? Okay. Then this is kind of the cool part. You're thinking like an engineer. Testing method. Are you going to use a wind tunnel to test this like we saw in the videos? Would you use something like an inclined plane where that's like a ramp that you just like send these two cars down and then you're going to see which one gets there the fastest? Maybe you're going to make something to do with the water that you're going to have like it in like, you're going to have the same like kind of like engine on a boat and then you're going to like send it down this river and then you're going to see which one reaches the end line first. So like a time trial test. Or maybe you even have like, not like a wind tunnel, maybe you just like put something in the wind, like you have like a couple different objects and you even just like blow and then you see which one moves like further. Yeah, so whatever kind of you want for a testing method. But if you were actually doing it, what would you do? Okay, then this one, really important. Real life application. Explain why this design would be important. Who would care? Who would care about this? Okay, who would be keen to use your design? Okay, why? Why is this design important? Okay, people who have done both of these things, I'm so sorry that you had to like re-listen to this. Maybe I'll say you guys can fast forward to like 10 minutes in the video. Okay, so that's that. Now, once you have done both of those things, you're done all of that and you're done the oxidization lab because those are the three things that are counting for like your homework. So hopefully they're like good marks, okay? Then you get to go into this, the thrill of flight. Alrighty, so cool. So what I suggest that you do today, okay, I've already run over this, but I suggest that you go into what is air, okay? Because all of this stuff, these three things are going to be on the quiz or the show what you know tomorrow. Okay, so enter into here. It's gonna be some wicked review. And it re-teaches you everything. It's amazing. Okay, maybe some of the videos are a little bit boring, but whatever. And then, yeah, you can just like look at all this stuff. Like there's some different activities you can click on these links to try it. Yeah, there's like little tests in here. This is about air compression, okay? Super cool. You could even try these like different experiments if you want to. Okay, a little bit more on Bernoulli's principal stuff. Bernoulli, air pressure, flight, lift, right? All this stuff that you guys can watch. It's amazing. So this, look, we even have this exact same thing that we did. Okay, perfect. Airfoil design, camber, right on. Okay, so, oh yeah, glossary. You can go into this. It's going to give you some of the terms. Oh, yeah, look at this. All these different terms that you might want to know about. Okay, yeah, okay. So there we go. Okay, if you want to go back, you always press this to bring you back to the home aviation center. And then you can just click even on like the exact one that you want to go to. Okay, or you can just navigate by doing this. Okay, all right. Okay, cool. Oops, what am I doing here? There we go. Okay, right on. Okay, so that is that for today. Stay tuned. At 2 o'clock, we're going to have a Zoom. So if you guys have any questions about this stuff, stay on the Zoom after 2 o'clock, because we're going to be doing like the breakout rooms for the social studies project. And then, yeah, I'll see you guys live again. So tomorrow at 1 o'clock to do this. Okay. All right. See you soon.